Welcome to The Explainer. Today, we're going to talk about something absolutely wild. We're diving into the incredible engineering story behind one of the largest live streaming events in history. We're going to look at the strategies, the custom-built tools, and really, the sheer nerve it took to keep a service online under some seriously unimaginable pressure. So let's just start with this number right here. 25.3 million. You know, that's more than the entire population of Australia, all watching the same cricket match, on the same platform, at the exact same moment. This isn't just a big number. It's the kind of number that completely changes the game for what we think is possible for a live event.
And yeah, this number wasn't just big. It was a brand new world record for concurrent live stream viewers. It was set by the streaming service Hotstar during a nail-biting cricket final. So how on earth do you even begin to build a system that can handle that kind of insane pressure without just collapsing?
Now, this kind of scale didn't happen overnight, but honestly, the growth was so fast it might as well have been. Look at this. The team started the season with an already massive peak of 10 million users. But week after week, that record just got shattered, climbing up to 18 million, and forcing them to target a completely unprecedented 25 million for the final. The goalposts weren't just moving, they were literally sprinting away.
See, at this kind of scale, the problems you face are they're a whole different ballgame. It's not just more traffic, it's a completely different beast. The engineering team didn't call it a traffic spike, they called it a tsunami. Because it hits all at once and it just washes away everything that isn't bolted down.
Okay, so picture this. It's a critical moment in the final match, right? A push notification hits 150 million phones saying, "You have to see this." What happens next?
You get this. Even a tiny 2% conversion rate on that notification means 3 million users are trying to open your app within seconds. Your traffic doesn't gently curve up, it becomes a vertical wall. Boom! You're spiking to 4 million requests per second, instantly. And it gets even worse. The danger doesn't stop there. If just one part of your system buckles under that initial wave, it triggers what's known as the thundering herd problem. All the users connected to that failed server instantly try to reconnect, creating the secondary wave of traffic that just slams into your remaining healthy servers, causing this catastrophic domino effect of failures. This is exactly why your standard cloud autoscaling just doesn't work here. You know, the hope is that as traffic rises, new servers magically appear to help out. But the reality with an instantaneous traffic spike like this is that autoscaling takes minutes to react. By then, it's way too late. Your system is already offline. Game over. So, facing problems that no off-the-shelf solution could possibly solve, the Hotstar team had to innovate. They basically had to build their own weapons to fight this digital tsunami, starting with their most important one. So first, they built their own weapon and they gave it the perfect name, Tsunami. Now this wasn't your standard load tester. It was specifically designed to replicate that sudden, coordinated, vertical wall of traffic they saw in real life. It let them repeatedly attack their own systems in a controlled way, find the breaking points, fix them, and then do it all over again.
And this ability to test led to a whole new playbook. Instead of reacting to traffic, they became proactive. It was like a military operation. They'd analyze the match to predict the peak moments, then pre-provision and warm up all the necessary server capacity hours in advance. So when that wave hit, they were already on high ground, just waiting for it.
But what happens if you're wrong? What if the traffic is even bigger than you planned for? Well, this is where their most critical strategy came into play: graceful degradation. And this wasn't just some technical fix, it was a fundamental business decision about what you're willing to sacrifice to protect the core experience.
They built what they called a panic mode. When the system detected that it was getting close to a breaking point, it would automatically start shutting down non-essential services. The social feed, the leaderboards, the fancy stats, poof, all gone. All the resources were diverted to protect the one thing that every single user came for, the video stream. Because it's way better to have a simple, working stream than a feature-rich, dead application.
So after surviving an event that would have absolutely destroyed most platforms, what are the key lessons here for anyone building resilient systems? Let's break down their core principles, because this is the good stuff.
First and foremost, their core philosophy was this: plan for 3 times your expected peak. So if the forecast was 25 million, they engineered for 75 million. This massive buffer wasn't just a safety net, it was the absolute foundation of their entire strategy.
And this philosophy was supported by a few key rules.
You've got to use tools like Toonami to find your breaking points before your users do. You need to control the flow of traffic with rate limiting, which is basically setting speed limits for requests at every layer of the system. You have to assume parts will fail and have a plan for it. You make graceful degradation a core feature, not an afterthought. And above all, you embrace a culture of relentless break-it-fix-it testing. Ultimately, the Hotstar story is so much more than a case study about big numbers. It's a masterclass in proactive engineering, in designing for failure, and in making really tough decisions under pressure. It proves that with the right preparation, you can build a system that doesn't just survive a tsunami, but actually sails right over it. Which really leaves a final question for any of us building something for the web.